Good morning, guys. Today we're going to continue with our notes from the other day. We're starting with classifying triangle ABC. Zach used the Pythagorean theorem to determine whether ABC was a right triangle. So Pythagorean theorem, just so we know, because we're going to have to do this later on, is taking a squared plus b squared equals c squared. Okay? So, now in doing so, we're looking at this, because a, we can see is 0, 4. Actually, so here, I'm sorry, this is how they look at it. As I'm looking up here, as this is A, this is B, and that is C. So they're seeing that A changed by 5, going down, and then B, they figured, I'm sorry, I flipped them around. Don't worry about it. So we're going to look at this, and we see that they did, A is 5 squared, B is 20, and C is 5 squared. So 5 plus 20 equals 25. 25 equals 25. Describe why Zach's reason is incorrect. Or I'm sorry, is correct. So, for Pythagorean theorem, we can say this. I'm going to write it right over on this side here. So it says Pythagorean theorem applies only to right triangles. Then since the side lengths of triangle ABC satisfies I'm just going to write just to make it short, theorem that triangle is a right triangle. That's essentially all you need to write. So it applies only to right triangles since the side lengths of triangle ABC satisfies Pythagorean theorem, the triangle is a right triangle. So meaning, since this is able to work out to being like that, means it's true and it's a right triangle. You can use the relationship among the sides of a triangle to determine whether the triangle is acute or obtuse. Given A, B, and C are the sides of a triangle with C as the longest side, when C squared is larger than or less than A squared plus B squared, the triangle is acute. When A or C squared is larger than A squared plus B squared, the triangle is obtuse. Okay, so, excuse me, sorry guys. So we look at this. C squared is equal to A squared plus B squared is a right triangle. Acute angle, when it's smaller, is C squared is smaller than A squared plus B squared. And obtuse, which is bigger, so 90 or larger, is when C squared is larger than A squared plus B squared. So essentially this is 90 degrees less than 90 greater than 90 is what you need to know this as. Okay? Determine whether each set of the side lengths creates an acute right or obtuse angle. So we're going to look at this first one. So we know C is going to be 42 because they said C is our largest. So that means 36 plus 15. We add these up. Let's see what they come out to be. So we add the 36 plus 15. We add it like this. We know 6 plus 5 gives us 11. So we add the 1 up there. 3 plus 1, 4. 51. Comes out to be a total. So we know since it's larger, 42, we know 52 or 51 I should say, is larger. Did I do it right? Hold on, guys. Sorry. They gave me the opposite. Hold on 1 second, guys. Because they just gave me the complete opposite of what we just came up with there. Oh, here. This is why. I'm sorry, guys. I just added them together. Erase this. I'm sorry. We have to do squares. So 42 squared, 36 squared, 15 squared. So we use our handy dandy calculators on there. I'm going to pull out my own. You can use your phone even. If you type in 42 squared, comes up with 1764 equals to 36 squared. 1296 plus 15 squared, which is 225. You add the 225 and 1296 together. Comes up to be 1521, 1764. So we know 1764 is larger. So we know this is going to be obtuse because we know that since c squared is larger than the other two, we know it's obtuse. Now if we go to this next one, 18.5 squared plus, I'm sorry, not plus, is equal to 11 squared plus 15 squared. So we know 15 already is 225. 11 squared is 121. And then 18.5 squared is 342.25. So we add the 121 plus 225, comes out to be 346. Well, that is larger than 342.25. So because this one is larger, C is smaller than A squared, B squared, we know it's an acute angle. So you can just write acute. And lastly, we got 60 square root of 65 squared is equal to 4 squared plus 7 squared. Okay, so let's see how this works. So 4 squared gives you 16. 7 squared gives you 49. And because this is a square root, and we're squaring at the same time, they cancel out. So it leaves you with 65. 16 plus 49 gives you 65. They're equal to each other. So you know that's going to be a right triangle then. Okay? That's what that just ends up being then, is a right triangle. Alright, graphing. We're going to graph triangle JKL now. Okay? We'll do this one and 4A, and then we'll call it a day. So our first point, I'm going to use the black for right now. Point J is -2 is our x, and 4 is our y. So we go to -2 on the x-axis, and we go up to 4. That's 1 point. We can label it as J. K is 8 on the x and 4 on the y. So we label that as our K. And then lastly, our L is +6x, -2y, which would be right there, and we can label that as L. So when we connect this, I'm going to use a red line to connect. You have that, that, and that. I'm going to fix that line. So that is your triangle of JKL. Okay. Next it says, consider the sides of JKL. Describe the triangle as scalene, isosceles, or equilateral. Okay. So now, if we go back and think about this, let me pull up my notes just to help you on this. So scalene, so equilateral, all equal. A scalene is no equal sides / angles. And isosceles is two equal sides or angles. Okay? So that is how you determine what a scalene is. Now, consider this. So we're looking at this, and we need to consider if it is an isosceles or not. So we need to look and see how long these sides are. Okay? So first off, we have to look J to K. So we're going to write JK. We're going to see how long that is. And we're going to count. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. J to K is a length of 10. Okay? Now we have to try and remember how we found out the angle here. Okay? I'm going to go back up to our notes because I don't recall off the top of my head. But it is in our notes here on how we did that. Where was it? Here we go. So we're going to take this part right here and use it down there. So square root of x2 minus x1 squared. So here it is. Square root of parentheses x2 minus x1 squared. I believe it was plus, plus y squared. Oop, I went a little too far. Plus y2 minus y1 squared. Okay, so now we got to figure these points. Okay, so we look at, let's go, this next one we're going to do is K to L. Okay, and then we'll do L to J. Okay, so we know our first point for K, we'll make, we'll go this our x1, y1, x2, y2. Okay, so we have to set this up as 8 minus 6 squared plus parentheses, we said 4 minus negative 2 squared. Okay, so 8 minus 6 gives us 2 plus 4, essentially it's going to be a 1 there, which makes that a positive. 4 plus 2 gives us 6 squared. Let me just, 2 times 2 is 4, plus 6 times 6 is 36, gives us 40, square root of 40, which comes out to be roughly 6.32. Okay, now we have to do our other one. So I'm going to do this one up here, so we have a little room. So our x, let's go, we're going to go L to J, so we're going to go L is our x1, J is our x2, this time, just so I don't have to write it again. Okay, so we have negative 2 minus 6 squared plus 4 minus negative 2 squared. And this is all under square root. So negative 2 minus 6 gives us negative 8 squared plus, once again we do this, which gives us positive 6 because it's essentially negative 1 times negative 2. Negative times negative is a positive. So it comes out to be 6 squared. Negative 8 squared comes out to be, should be 64 plus 36, we said is 6 times 6, which we add all these together, comes out to be 100, and square root of 100 is just 10. So from looking at this, we can see that since side JK and LJ are the same length, we know right away that this will be an isosceles triangle. And that is your answer. We're going to stop there today. We'll pick up tomorrow and do the other part, the rest of this tomorrow. Have a great day, guys.